In section 5.4, these are all the formulas that we're going to be working with today that pertain to the unit circle. You're going to have to know information about your unit circle pretty well. And so as we do that, what I want to talk about is all these different examples that we're going to do today. Every single one of these examples, I'm going to be referring back to this set of formulas that we see here on the screen right now. Example number 1. Grab your unit circle, take a look at the sine of 15 degrees on your unit circle. Joe?
1/2.
Sorry, incorrect. Mason?
1/4.
Sorry, Sam?
Oh.
The deal is, if you don't know what's going on, what you want to do is you want to try and rename 15 degrees so that you can use the unit circle. That's kind of the whole point. So the big key today is we want to use unit circle values. And since we notice that this 15 degrees is not on the unit circle, I'm going to change it. This is what I mean. Sine of 15 degrees is the same as saying the sine of, and one way I could do this is 45 minus 30 degrees. Because 45 minus 30 is 15, and both 45 and 30 are on the unit circle.
Yeah.
As you look at your formula sheet, do you notice that on that formula sheet, there's something that says this: the sine of u minus v equals the sine of u times the cosine of v minus the cosine of u sine of v. You guys all see that? On the formula sheet, it's the top right-hand formula. The u is representing the first angle in the parentheses. The v is representing the second. So in our case, the u is the 45 degrees and the v is the 30 degrees. That means that I would rewrite the stuff in blue as the sine of that 45 minus 30 is really going to be the same thing as the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. So now that I've used the orange formula from my sheet and plugged in the values from my blue rewrite of the sine of 15, I'm just going to start evaluating. So the sine of 45 is the square root of 2 over 2 from the unit circle. The cosine of 30 is the square root of 3 over 2 from the unit circle. The cosine of 45 is the square root of 2 over 2 from the unit circle. And the sine of 30 is 1/2 from the unit circle. These are all coming off the unit circle. If I put these things together, what I see is, in the left-hand side, I have the square root of 6, because 2 times 3 is 6, all over 4. And then square root of 2 times 1 is the square root of 2, all over 4. And if I were to simplify that and put it as all one fraction, I would write it as the square root of 6 minus the square root of 2, all over 4. And that cannot be simplified any further. Okay, I don't know about you guys, but oftentimes it's easier for me to work with these sum and difference formulas if I have it in degrees rather than radians, especially when like I'm pi over 12. So I'm going to take that pi over 12 and I'm going to change it to start out with into degrees, just so I know what's going on. So if I change that into degrees, that's when I multiply what I see by 360 over 2 pi. Again, all I'm doing is converting this to degrees so I can see it. My brain works better when I'm trying to do sum and differences in degrees. when I do that and I simplify it, you find out you get 105 degrees. You can check that out on your own, but what I want you to know is 7 pi over 12 is the same as 105. Remember, this is a take-home. You can use your calculator to figure this out, so if you have difficulty with that, come see me later. Now, because I can use addition or subtraction for this, it doesn't matter which you use. In fact, there are lots of ways that people can do these problems. And again, like yesterday, I'm going to pick one way. It's not the only way, but as always, it's the best way. So I'm going to write down the cosine of 105 degrees, which I've now changed into degrees instead of radians, as the cosine of 45 degrees plus 60 degrees. Why? Because 105 is not on the unit circle, but 45 and 60 are. Now I go look at my formula sheet. And in my formula sheet, I look for a cosine that has a plus thing of 2 angles. So that formula is the cosine of u plus v, which says to me that I'm supposed to be taking the cosine of u, cosine of v, minus the sine of u, sine of v. If I use the stuff in the red that I've already written down, and I now fill in these things, what that means is that I have the cosine of 45, cosine 60, minus sine 45, sine 60. So I'm plugging in the 2 angles. Whatever came first was the u, whatever came second in the parentheses was the v. Shove them right into the formula. Then all you have to do is go look at your unit circle. So the cosine of 45 degrees is root 2 over 2. Cosine of 60 is 1/2. Sine of 45 degrees is root 2 over 2. Sine of 60 is root 3 over 2. This probably looks a little bit familiar. So this is the square root of 2 all over 4 minus the square root of 6 all over 4. And then my final answer is the square root of 2 minus the square root of 6 all over the common denominator of 4. It's basically going backwards. So in number 3, they write it out as the formula with the 2 angles. And what you'll notice is that these 2 things that come first, 78, those things are 1 angle, which we would probably say is probably going to be the u angle. And then the second thing, the 18, that's the v angle. So I'm looking for a formula that says cosine, cosine plus sine, sine. When I see that, the formula that I'm then looking at is this formula. The cosine of u minus v says that I have the cosine of u cosine of v minus the sine, plus sine u sine v. Can you guys see that on your formula sheet?
Yeah.
So then what that's saying to me is that really, when I look at this stuff, I really have the cosine of 78 minus 18. That's what it's saying to me. So this was my v, and this was my u that I was talking about from the listed out formula. And the cool thing about that is that what's going on then is that you're really saying this is the cosine of 60 degrees.
Yeah.
And if you look on your unit circle, the cosine of 60 is 1/2, and so that's your answer. In my opinion, the tangent formulas are the ones that are a little bit frustrating, and that's because they are, if you look, fractions. Okay? So you have to work with that. So